It's on in 3, 2, 1.
Yeah, it's on the same website.
All right, you guys. 21B. What is it? What did it ask? Yeah. So we have like what you need is like since A and C are changing. I did the sign because like you got this changing, you got this changing. You know, you got all of that going. Okay. So if I take the derivative of this, what do I get? And all of this, take the derivative according to t, and what do I get? Yep. Cos theta, d theta dt, or theta prime, is equal to quotient rule. A prime c minus ac prime all over c squared. Again, all of these are changing according to time. A is changing, c is changing, and theta is changing according to time. Okie dokie? Now I think from here we have all that information, right? Okay, good. So again, get this and then finish this one to see if you can get it to match up with your answer in your book. 24. I should have done it the other way because you want the liquid to be blue. You know what I'm saying? We got green coffee. All right. What's the first question that this is asking, Jesse? In 24, the coffee problem. How fast is what changing? The pot. So the pot's down here. How fast is the level changing in the pot? What do I know about the pot? Any formulas or anything? I know the volume. What's the volume of a, this looks like a cylinder. V of pot is equal to pi r squared h. Okay, we have our relationship, our geometric relationship. Sure, for this related rate problem, we've got to write some geometric relationship. Done. Next thing we do, are any of these things constant?
The radius.
The radius is squared, right? This isn't expanding, it's just going up. Yes? So you can plug it in right in the beginning. So what's the radius of this pot? Okay, 3 what? Okay, cool. So we have the volume of the pot is equal to 9 pi h. Do I know the change in volume over change in time is what? Now, was that 10, and be careful, is that for the pot or for the cone?
Is it both?
Is it? Is it?
I think it is. It'd be negative for the phone.
It is the correct number. One thing is dumping out, and the other thing is catching all of that value. So the value is the same. This is losing it. This is gaining it. This has a positive 10 volume change. This has a negative 10 volume change. Does that make sense, Jessica? That's kind of a trick. It just shows us one number. It's like, well, which one's this? Yes, this thing is losing 10, and this thing is gaining 10. So I have a change in volume, and I want to know a change in height. So let's take the derivative of V equals 9 pi h. And what do I get? What is the derivative of V equals 9 pi h? V prime of the pot, or dV dt of the pot, is equal to 9 pi h prime. Yes? Or dH dt. dV dt equals 9 pi dH dt. So interesting relationship here. There's a direct relationship between the change in height and the change in volume. I have this number, so I can directly solve for h prime. This was 10. Was it cubic inches per minute?
Yeah.
Okay, so this is 10 equals 9 pi h prime. So h prime, and what was that number? And then what are my units? Don't want to lose that number. Inches per minute. And check how this would make sense. Since this was v cubed divided by minutes, and inches cubed, and I just divided by inches squared. So it leaves me with inches per minute. Does that make sense? Or forget all the units and then just track it at the end. But what you should check is, okay, does the sign make sense? Does it make sense that the height is going up? It's a positive? Yeah. Okay. So if you forget a sign, sometimes this thing increasing or decreasing, check your final answer and say, oh shoot, is this thing going bigger or smaller? This height is increasing, so it should be positive. All right, 3 decimal places with units. Don't lose any of those points. All right, so great. This was the pot. Now let's talk about the cone. And see, like the pot didn't depend anything on that when the cone is 5 inches in height. Did anyone notice that? It's kind of like, where do I use that? You don't. There's just a relationship between this and this. Do you see that, Allie? So now let's talk about the pot. So we have a geometric volume equation for a cone. What do we got? Okay. Is it 1/3? Okay, I'm going to write it as pi over 3. Do you guys mind if I write it as pi over 3? Or 1/3 times pi? Okay. All right, well, and we need our change in volume equation. So what are we thinking here? Is radius changing? As it goes down, is that radius changing? Yes. Is the height changing? Yes, they should have a derivative then. Let's take the derivative of pi over 3 r squared h in your groups. If you didn't do it already, check it out, try it. If you haven't, check your partner, see how they're looking. I want the derivative of this. What rule are we thinking? Yeah, it's going to be a chain rule, but overall product rule. Then we're going to chain rule that guy. So let's product rule it. Check the person next to you. Don't let them hide today.